Who are we missing?
It's like 1 over this stuff times the derivatives.
Who are you guys missing? Cameron, was it just the two of you? You're not missing anyone, it's just the two of you? Okay. Alright, so some of you are looking like you're done with this. So find the tangent line at 0. Okay, how do I find, well, what do I need to get a tangent line? A slope, so the derivative, and what else? A point. So, Ray, what is the coordinate?
Coordinate?
Yeah, I need a coordinate to find the tangent line, so.
0, 0.
So the coordinate is 0, 0. Do not leave natural log of 1. You will lose points on my quizzes and tests. You need to know that natural log of 1 is 0 and without a calculator. Those of you who don't know, I don't know. This is saying e to what power is 1? E to the 0. Stella, we also said that we need a slope, so how do I get a slope? From this, okay, how do I, what is the derivative of natural log of x plus 1? Stella? Don't know? Matthias?
1 over x plus 1.
Derivative of natural log is 1 over stuff times the derivative of stuff, which derivative of stuff here is just 1. Roman, what is, so we got the coordinate at 0, what is the slope at 0?
Slope of 0 is 1.
1, okay, cool. Sita, can you put the pieces together and give us the tangent line?
Just y equals x.
Okay, well, let's see, y minus the y value equals slope times x minus the x value. Yeah, so just y equals x. And, right, I changed the homework, which is on your sheet as the change thing already anyway, but your textbook, oh, this will make sense in a minute. They're gonna call it L of x, this tangent line. It's on the next page, sorry, I'm too early with this. Okay, so Alex, I now have this tangent line. It says, use your tangent line to approximate g of x at x is 0.2. So Alex, how do I do that?
Look at this line.
So what do I get?
0.2.
0.2. So what this is saying is g of 0.2, which is asking you to find the natural log of 1.2 but that's going to be approximately the x that you plugged in, which is just 0.2. So check on your calculator. It's going to take me a minute to bring mine up. But what is natural log of 1.2? Point 1823, blah, blah, blah. So it's close to 0.2. Now that we know the answer, the next question, I should have done this first, order of operations here. So our approximation 0.2 is bigger than the 0.18. I want a math reason, a way to prove that. Anybody have any suggestion how we're gonna know, other than brute force typing it in? Evan?
With the second derivative,
Why the second derivative? What does that give you?
lets us know the rate at which the slope is changing.
Okay, gives you this rate at which the slope is changing, also known as concavity. How curvy is it? So if it's curvy this way, the tangent line's gonna sit on top, right? Or if it's curvy this way, no matter where you are on it, the tangent line's gonna sit below. Okay, so Flynn, to be able to answer this without just typing it in and looking, I need the second derivative. So what is the second derivative? Multiply by the power, lower the power. And then chain will multiply by the derivative stuff inside, which is still 1. So there it is. And this, it doesn't matter what x value you plug in, it is always negative. So my n, is it concave up or concave down?
Concave down.
It's always concave down. So is it an over or under approximation? Natalia, what do you think?
So,
Over, because the tangent line's gonna sit on top, and that, wherever you are, a little bit, it's gonna be a little bit over. Okay? This is the same question, exactly the same question, except they use the words, find the linearization, which Sita did and said it's y equals x. Your textbook will call it L of x, the linearization of, okay, so what? And this is their way of saying, what is the function when the x value is 0.2? But are you okay with this wording of the same problem you did without learning anything new? Okay. Well, that's linearization. So the homework is on delta math today. Some of you might have already done it because it's been out for a few days because I rearranged things. Can you guys try that one? Find the linearization of the square root of x, and then use it to approximate square root of 122. So Adrian, it just needs find the tangent line.
What explanation? Explanation is your explanation.
Just plug in.
Okay. Sure, yes, you need a point to plug in, and I didn't specify. Where do you think you should choose, what X value should you choose that makes, is a place you know? 121. So find your tangent line at 121. Why that? Because I know the square root of 121, which is? Yes. So find your tangent line there. Because I didn't specify, I just want to show you the difference. Like, I'm going to pick an easier square root to do. I'm going to pick 100. So if I want to use my approximation, f of 122 is approximately 11 and 1 over 22. And AP might ask you to do a linearization, no calculator. It's in your best interest to leave this because it's going to come out to be potentially something nice. And I highly recommend you leave it as fractions. Okay, so 11 and 1/22. If I am choosing this one, do you think my answer is going to be closer or further away? It's like, okay, so 121 is closer to 122. 100 is kind of far away, so it's greater error. So sometimes it works, sometimes it doesn't. Okay, let's try 11. So that's my approximation, and it is close to 3 decimals. If I use the one that I created the tangent line, I'm off by kind of a lot. So I linearization. Here's my square root. If I was doing the tangent line out here, approximating the square root of 122 using the anchor point of 121, it's not going to be so bad versus if I went here, tangent line's going to be off by more. So the point of linearization is finding the exact point was a pain. Finding some nice nearby thing and using that to approximate, all good. And my brother's an engineer, does this approximation thing all the time because the amount of calculations he needs to do for, I don't know, missile targeting, it's time critical and accuracy matters. So thousands of computations to do in a second to make sure stuff goes where we want it to. We don't want to blow up Roman. We don't want to hit Jason. Sorry, Roman. You're right in front of me. You're the target. Okay. And is it an over or under approximation? Doing the derivative again. Multiply by the power, lower the power. It's always negative, so because the second derivative is negative, it's concave down and the tangent line is above, so it's an over approximation. Cool. Yay, those of you wearing sweatshirts, it's gonna be hot, they turned the heat on. Yay. Don't want to do that. Okay, too many words. Just want to, they're going to use the term differential on some things. You don't need to know anything other than the fact that where we had been saying dy dx equals f prime, we're now going to treat that dy dx as a fraction, and we can multiply dx to the other side. So the change in y is equal to the derivative times dx. It's just a fraction. You guys okay with that? It really bothered me, but I have a different math brain. It ticked me off. So this is a thing for manufacturing. Like, how accurate does it need to be so that we have construction tolerance within this range? We'll use differentials. But we will also get to this in integration. Physics people, you've been doing integration since like day 2, right? No? Yes? Are you saying yes? Okay, AP Physics versus Honors Physics. Honors Physics is supposed to be non-calculus related and you memorize all the kinematics equations and have no understanding of why those equations work, right? Pretty much. And those of you doing AP Physics with calculus, you haven't learned that calculus yet. It's coming. You will know by Christmas, but sorry, winter break. Can't use secular things. Anyway. Differentials. Just comment on notation. dx is how much you're taking a step in x in our derivatives or whatever, your infinitesimally small slices. What does the triangle mean? Delta. delta x. Right here, there is no difference between dx and delta x. One is for our approximation, we are doing this. And the other is our actual change in x, delta. This big one is our real change in y. And the little guy, our approximation, is dy. So delta is the real change, and d is the approximated change. Does that matter? Probably not in anything that you do. But there's that. Okay, so I would like you guys to use the rest of the time to do the delta math and to make sure that you can do the 4.6 questions, because tomorrow you will be answering questions from the class. Those of you that were assigned, let's see, problem 29, they're gonna ask. 17 and 21 often asked. So you guys are answering the class tomorrow, so be prepared. Okay? Any questions? So, in class tomorrow is homework day. Look, also, guys, test. There is a 2-day test because I can't put a related rates question and an optimization question on the same test in the same day because they take too long. So, you're gonna have a 2-day test. Next week, Tuesday and Wednesday. First day is non-calculator, second day is with calculator. So tomorrow and Monday are just to go over homework questions and review for the test. Tomorrow is largely going over the related rates questions, which you guys should be experts on your particular question. If you don't remember what your particular question was, there they are. So, 29, 17 wasn't so bad. Was the shadow question, right? And the coffee pot problem, maybe that was yours, yeah? Reservoir, okay, that might come up, just. Come on.